Hello everyone, and this is lesson 7 in the patterns and texture series, and we're going to take a look at all the noise maps that are available in Houdini. So this one, I took a long break in the middle because I was uploading all the UI training stuff, and now I'm sort of back to this. The problem that happens with me is that when I finish a large series, then my brain gets confused as to what I want to do next. And I completely sort of forgot about this one, that I was, supposed to record the second half of this. So now I'm finally sort of back to recording the second half of this. So there are about 6 or 7 more lessons. I'll upload them over June and July. In the first section of this, we primarily covered all the 2D maps, right? Like all the 2D textures and patterns that are available. So in this section, this will be the more interesting stuff. We're going to cover all the noise maps, and we're going to see how to use them to affect geometry, height maps, and VDBs. Okay, so eventually what I want to do is I want to cover like these 2 projects that I did. Like this one was primarily, I did this to sort of go through all the various noise maps to affect and how to use them to affect VDBs, right? Like this is the clay render of it. So this is entirely like the spike over here, the rock spike and this big thingy, they're all like VDB. And then even this one, like this is almost like leaving out the tree and that tiny little figure over there, this is entirely VDB. So this is what I eventually want to get to. Okay, but and then stuff like this, which is just creating like abstract patterns and things like that. But before that, what we'll do is we need to cover the basics, right? So Houdini gives you a fair bit of noise maps, right? Like not as many as Cinema 4D. Like Cinema 4D probably has like the largest library of noise maps you can get, but Houdini gives you a fair bit. Okay, and then because Warps is such an open system, you can pretty much modify them any which way you feel like. So to get started, right, I'm just going to do it on a grid for now, and then towards the end of this lesson, depending on the length of it, I'll also show you how to use the same noise maps for height fields and for VDBs. Okay, and then we'll continue on to see how to modify noise maps and distort them and do other things with them. Okay, so to get started, what I'll do is I'll just take this and I'll make it like a 1K image. So I'll make it like 1024 by 1024. Right, so we just have like a 1K image. Okay, so to get started, the nice thing is with noise maps, you don't need to do UVs. I mean, you can if you want to, but you don't really need to. Okay, so what we'll do is I'm just going to take an attribute warp straight up. Okay, and we'll call this noise, and I can connect this in. Now, the reason I'm doing this at SOP level and not in Mantra is because then if I do it in Mantra, then you're just limited to using Mantra. Doing it at SOP level, you can use them to modify a lot more things, but then you can also use whatever render engine that you want. So you're not limited to just having, just limited to Mantra. Okay, so to get started, if you press tab and then you'll find a section called noise. Okay, and you have a bunch of these. If you're doing like shading stuff or, just you want like a variety of noise maps, the 2 that you want to use are turbulent noise and unified noise. There's unified noise and unified noise static. Unified noise static is the one that you want to use because it's faster. I honestly don't know the difference between them, but unified noise static functions a lot faster than unified noise. Okay, and then you have all of these other ones, like you have periodic noise and you have periodic whirly noise. But I think they have sort of combined all of these and put them into the unified noise. Okay, so because unified noise has options for periodic noise and all the various sort of whirly and Voronoi patterns that are there. So all of those are available inside unified noise. Okay, and then turbulent noise is the original one, which also has some decent bit. Okay, so to get started, I'll just take turbulent noise. And what you need to do is the position is where you connect your UV or your position data. If you're going to do this in Mantra, if you're just using position data, right, like world space or object space, you need to have like a rest position in the middle. Okay, so I don't think it will be here. Yeah, you have like a dual rest. No, that's not the one. But when you're working in Mantra, in like at shader level, there will be a rest node. So you have to make sure that the position connects to the rest node and then connects into the noise. Okay, otherwise the noise will swim. But if you're at geometry level, it doesn't matter. You can just connect the position to this, and then I can just take this noise and plug it into color, and that's pretty much it. You get a noise map. Now you get two types. You get like 1D noise or 3D noise. 3D noise is something that you want to use when you are trying to build like a vector field, right? Like if you're trying to do, if you're trying to modify another noise map using a noise map, then that the modifying noise map should be 3D. Or if you want to use a noise map to generate like a velocity field or anything like that, then the noise map needs to be 3D. But if you're using it for texturing work, you keep it at 1D. Okay, so you have about 6 types in here. And the parameters are fairly simple. So let's just go through the 6 types. Okay, so you have Perlin noise. Okay, and let's do one thing, right? Let's just copy paste this. So Control C. Okay, so we are currently at the standard one, which is the Perlin noise. And let's come into the second one. We'll set this to original Perlin. Okay, this is getting slow now because it's a fair bit of geometry. Let's do one thing. Let's bring this down to 512. Okay, that'll be a little faster. Okay, so that's original Perlin. This is Perlin. I'll just set up all of them and then we'll come back. Okay, so this is sparse convolutions. This is alligator noise. Alligator noise is actually good for doing gravel, doing rocks and stones. Also, you can do like skin with it, which is primarily where it gets its name from. And then you get simplex noise, okay, which is this. And then finally you get which is the last one? Yeah, zero centered Perlin. So these are all the various noise maps that are available inside the turbulent noise. Okay, now to go back to the basic, okay, which is, I'll just get rid of all of these. Okay, now Perlin noise, it's better to use like original Perlin. Okay, but the problem that happens is if you come to original Perlin, you'll notice like there are a lot of black spots in there. The reason for that is that the range for the Perlin noise, or the original Perlin noise, is minus 0.5 to plus 0.5. Okay, and this is trying to show it between like 0 and 1, which is why you're getting like these dark spots. Okay, like your value is actually going negative. I think if we come into the geometry spreadsheet, we should be able to see it. Because if we come into geometry spreadsheet, if you come into the color, I am very sure, see, you have values going into negative. Okay, so that's the problem. So what you need to do is, especially like when you're working with almost anything except Perlin noise, because you'll notice like all of them have these really dark areas. Okay, like simplex also does that, and zero centered Perlin also does that. Okay, so what you need to do is you need to take like a fit range unclamped in the middle, and then set the source minimum and source maximum to minus 0.5 to plus 0.5, and like this is the range that you want to work with. So see, now you don't have any values going into negative, right? Like this is good. So that's the one thing you need to remember, especially like if you're working with this. Otherwise, you can also see what it does, because if you take like a displace along normal, and if I just connect this directly into the amount and I plug this into position, you'll notice like, see, some of this goes into negative. Like if I look at my grid, okay, and if you come to like, see, there you go. So you have some of it going into negative. But if I take the fit range and I plug that into amount, see, now this is all over 0. So that is something that, of course, it's not necessary for you to do this. But if that is going to be a problem, like where you don't want the noise values to go negative, it's a good idea to have like a fit range in the middle. Okay, now values wise or parameters wise, this is fairly simple, right? So you have frequency. The one thing you want to do, right, like if you zoom out, you'll notice like there's like a star pattern happening in the middle. Okay, like you can see these stretch lines. You do it with any one of them, you'll see like this pattern forming in the middle. Okay, see, like even this has like a like a star coming. What you generally want to do is you want to offset the noise a little bit. Okay, like come to a separate section of it, and then you won't see that happening, because you will see that. Like with, I think it's a thing that with noise maps, because I've noticed it in almost any software. You use a Perlin noise or any kind of a standard fractal noise, and you'll see like that at 0, you see like this star burst happening in the middle. Okay, so you have like frequency, okay, which is the repeat, or not the repeat, but like, you know, how small the noise will be. Okay, offset, as I said, like offset moves it. Okay, so whichever axis you want to move it in. It's a flat plane right now, so moving it in Y sort of gives you just like, you know, movement like this. Okay. You have the amplitude, so you know, you can go negative or you can go positive. Roughness is the detail. So roughness at 0 is like, this is, okay, 0 goes weird, but anyways, okay, so this is like the absolute basic noise, and then as you increase it, you get more and more detail into it. Attenuation is kind of like contrast, right? Like if you get it really low, you'll see like it removes the gradation in the noise. Like if you get it really small, see, you just get like these very strong patterns. This is actually good for doing, if you want to do like a planet and you want to do like land masses and stuff like that, or you just want to do like a map, this is really good for that. Like if I just take this, like let's say if I keep it really low, okay, and what I can do is, just to sort of like, since we're doing this just for fun, I can take you can take a ramp parameter, and let's call this as color. So I'll plug in the input over here, and then this goes over there, and let's give it a slight bit of a blur. Okay, so I can do this. Okay. And then what I can do is I can just come up here, and let's say this is water and then this is land. Okay, so I can just take this, and let's say this is maybe like green or something, and let's say the border will be like slightly brownish, and then we want maybe blue on the edge over here to show water, like, or like, you know, shallow water, and then this will be dark blue. Yeah, so there you go, you know, so you can do like a very simple landmass if you want. And then what you can do is you can take the noise over here, okay, and then we can actually like adjust it. See, so you can sort of adjust these values, okay, or what we can do is, let's say after this, I can take another fit range. Okay, the difference between e-fit and fit is that fit range will clamp it, right? Like if you set it to 0 to 1, it will remove the values that are above 1 and values below 0. With clamping, it does, with the fit range unclamped, it doesn't do that. Sometimes you want this, sometimes you want the normal fit range, especially if you're feeding it into color, okay, so that the color ranges don't go, you know, crazy. So I can just drop this in the middle, and I can take this and see, you can actually like, you know, adjust this if you want, or let's do one thing. See, so yeah, so if I start to increase this, you can actually, you know, like reduce the landmass. So you want to do like islands, we can do islands. Let's try to remove that. Yeah, okay, that doesn't do anything, so fine. Okay. And then what you can do is I can take this, and then I can just feed the same thing into a mount, and I can create that. Okay, now this is where you need a fit range, okay, because now your values are like really crazy. Okay, so what I can do is, if you drop a fit range in the middle, it will control that. See, so there you go. So what the fit range does is just clamps everything that is down at 0. And we can take the scale and drop it down a little bit. Yeah, there you go. You can also try to just see, if you increase this, it doesn't clamp it. You know, like if you want like a little bit of noise over there, and then here I can just make some slight adjustments. So yeah, so this is something that you can do. Most noise maps are, especially like your sparse convolution and original Perlin, they are really good for doing, you know, terrains and stuff. That's what they get used the most. Okay, I'll just make another one. Let me keep this. Okay, so I'll just call this as islands. Okay, let's take another attribute warp and we'll plug this into noise. Okay, and again I'll just pick up a turbulent noise. Yeah, so there you go. Okay, let's talk about roughness and turbulence. Okay, I think most of you might understand this stuff, but for those of you who don't, I'll try my best to explain it. So turbulence is sort of like the number of repeats in your like each turbulence level gives you smaller and smaller and smaller detail. That's the simplest way to explain it. So if I plug this into a displace, right, that's probably the best place where you can see it happen. Okay, so I can just plug this into displace, and sorry, not in position, this goes into amount. Yeah, okay, and I'll get it out from this. So the best place where you can see it happen is like if I get the turbulence down to 0, this is what you get. So if the turbulence is 0, it doesn't matter what your roughness value is. Like it just doesn't have anything to add. So if I get a turbulence of 1, you'll see like it adds, one level of additional detail. Okay. Like it keeps increasing the intensity of that, but then nothing moves beyond that. Oh, that's interesting. So if you go to 1, it does this. If you go to 0, it does nothing. Okay, but anyways, like the stuff in the middle is what matters. So as you increase this more and more, let me just take this a little higher. I'll make it like 1024 by 1024. Okay. So as you get the turbulence value higher, like when I get it to 2, see you'll get like one more level of detail. You get it to 3, you get another. Okay, this is 4. And like, so on and so forth. As you keep going on, you'll notice like, you get smaller and smaller detail, right? Like if I get it up to, see, there you go. Like you can make out, let me go higher. You don't want to go this high in the viewport, it's just unnecessary, but there you go. See, now you can see like the level of detail. Okay, so this is 1 and this is 2 and 3 and 4. So it keeps adding, more and more detail. So this is all the way up to 10. So then as you go up, like, so roughness is then sort of connected to turbulence. So as you start to increase it now, you'll notice that it keeps adding, like way more. See, it becomes this by the end of it, which is insane. But like now if I bring the turbulence back down to about 6, you'll notice like all of that detail disappears. So yeah, so these two are connected. Okay, like this is like very important to know that. Okay, now another way to, I'll go back to 512. Okay, another way to control the noise is through a ramp. Okay, like we saw controlling it through a color ramp, but then you can also control it through like a spline ramp. So what I can do is, let's say if I come to original Perlin and I'll do a fit range, a fit range unclamped. And let's make it minus 0.5 to 0.5. Okay. Or let's keep it to 0 and 1. It doesn't really matter. But what I can do is, if I put in like a ramp in the middle, and we can call it shape, and we'll keep it to spline ramp. So if we drop this in the middle, you can now sort of control it a lot more. See, okay, now the first thing that happens is when you put in a ramp, it automatically puts a clamp on it. Okay, so all your negative data is gone. Okay, so what we'll do is we'll just come into the fit range and I'll make it like minus 0.5, so that we have like, all the data that we want, and let's make this at 0.5. So now what I can do is I can start to adjust this. See, so I can control this any which way I want. Or if I want to, like, let's make this into like B-spline. Yeah, so I can just take this and see. So this kind of control you won't get, at warp level. Like you will have to add like a ramp parameter and then control it. So if I want to make these to be slightly rounded like that, then you can do those things. And I can come into displace, maybe lower the amount. See, so you can get, which otherwise you can't. Like if I remove this, see, like this is the best shape that you'll get. So with the spline ramp, it gives you, way more control over the whole thing. And if I make it like say 1024, and then I can try to increase the roughness of this. So let's bring this up to 7. See, there you go. Even just directly bring it up to 7 makes it, or 8 makes it a lot more. Like default is at 5 or 4. Yeah, default is at 5. So if I get it up to 8, see, there you go. You immediately get like a lot more detail on the whole thing. And then maybe I can just try to put in like another ramp parameter. We'll call it color. And let's see, let's try to put in this guy over here and put this into CD. Or let's try to put in this, see what happens. Yeah, okay. So that way, like whatever changes I make to the shape, the color will automatically readjust. Okay, so let's say if this is supposed to be like a desert or something, so I'll make this into, you know, a desert shade like sand or whatever, and then I can take this and make these into like dark rocks or whatever. Yeah, there you go. Okay, so I can just take this and then just push it down a lot. Okay, so that's not bad. So the nice part about this is now if I make any changes here, so you'll see like the color map automatically readjusts. And if you want this to like flatten out to the top, I can just make this flat over here. See, there you go. So if you want to like cliffs and things like that, this is pretty useful. Okay, so the question that comes up is like, since we're doing this, let's say you want to transfer this to a height field. Okay, so how exactly do you go about doing that? So what I can do is, let's say if I take a height field, and the height field is default like 1000 by 1000. So this is, and our grid over here is 2 by 2. Okay, so what I can do is if I take the height field and I'll zoom out, and maybe this will work. Okay, so what I can do is, let's take this, and we don't need the color because the color won't work. Okay, I'm just going to take like these three. We'll do Control C. And what you can do is, you can take a height field warp. And in order to fit the noise map to the height field, don't take the position. What you want to do is you want to take the bounding box. So let me just paste this here. And let's try something. So what I can do is I can come to my original shape over here, like in this noise map. I can right click over here. I can say copy values, or I can say copy parameter. Come to the height field warp, right click and say paste values. So it will take the exact shape and, you know, paste it over there. So now what I can do is I need to apply this to my height field. Okay, so the way it works is, firstly, let's take the bounding box and plug this into position. So hopefully that should work. And then you need to set up a bind export. And we add the noise map to our basic height field. Okay, so I can take this shape value, or I can take the height first. Let's take the height first. Okay. And we might also need a multiplier. Okay, so let's take a multiply constant and plug this in. And then that goes into the add, and all of this comes into the bind export. Sorry, we need a bind export. So take a bind export. Yeah, and type in height, because that's the volume field that you want to modify. Okay, so just plug that in, and then take the multiplier and let's make it 100, and there you go. Let's make it 500. Let's see. So if I zoom into this, almost, you know, but yeah, you're sort of like now replicating those same values over here. I think we might have to sort of increase this, because yeah, that was 2 by 2 and this is like 1000 by 1000, so it's not matching exactly, but we are pretty much in the same area. So the color data won't come in because the color data in height fields is done differently. But there you go, you know, like you can, so if you want to take like these custom noise maps that you've made and apply them, this is how you can sort of, you know, go from geometry to a height field. Okay, let's go back to the geometry. Okay, so I'll just take this and go back. Okay, so this is as far as, you know, the basic noise map is concerned. Like you have different varieties here, so you can just try them out. You know, so like this is with alligator noise. Alligator noise is also good for doing terrains. Actually, this looks pretty good. Okay, like let's try that over there. Like if you just want to create something basic here, like if I just take this and I turn this into alligator noise, and you can try to, like, you know, adjust the shape a bit more. There you go. See. And we can come into the height field, make it like say 0.8. See. And then I can just take maybe, let's do a mask by feature. Like if you just want to create like a rocky terrain very, very quickly, and then I can just take a slump. This is like the fastest way to create. Like if we just take a slump, so this is like all the sand that has come down, and I can do a copy layer. So let's do a height field copy layer. I'll copy this to slump. So we've created like a custom field called slump. Okay, like there you go, slump. Okay, and then I'll clear out the mask. And let's just take a height field visualize. And I want to get rid of all of this, right? So let's say we just want to do like something very, very simple. So let's say this is all rock. So it's just dark gray. And then this is the sand. So I can just say slump, and this will be, you know, like the sand over there. Yeah, there you go. See. So just like one alligator noise and then, you know, applying slump to this. And because slump calculates very quickly, if you just come back to like the height field warp and we make any kind of changes to this, like if I take this and I make it flatter, or, you know, let's go in a bit, you'll see like everything kind of readjusting. See, so you can actually like, you know, you can make changes pretty quickly. Like if I take this and just move the point, or let's try to do that. Yeah, there you go. See. So it's pretty easy to do this stuff if you know, what noise maps you're working with. Okay, now, so I'll just, I don't know, let's call this terrain. Okay, so let's make another one and we'll go through the unified noise. So I'm not going through the rest, I'm not going through like the anti-aliased noise, the anti-aliased flow noise. They're all like, they're not bad, but they don't really have enough variety. Like they're very simple. Okay, so they're good for some things, but not really like if you want to do complex shading and you want to do like complex noise maps, there just isn't enough there for you to do modifications with. So let's take unified noise static, and unified noise is huge. It's also a little slow because it's just got a lot of parameters in it. Okay, so the only weird bit about unified noise is that you can't promote the noise type, right? Like if you come into turbulent noise, you'll see that you can actually promote the noise type. Okay, but you can't do that with this. Okay, I got a bird out there screaming. Stop screaming. Okay, so the first issue that happens is the position is way down there. Okay, so when you need to connect it, you have to go like all the way down here for you to connect it. And then I can just plug this into, let's take a displace. Displace is easy to show like what's happening. So we'll take displace along normal and then plug this into amount, and let's also plug it into color. So both places. And this comes into position. Okay, there you go. Okay, so let me just minimize this for now. This is a huge node. And we lower the displace amount. Okay. Okay, so what you have is, like this has a lot of different types. Okay, so even if you don't use turbulent noise, right, you can actually just work with this and it's good enough. Okay, the only thing that's missing is the attenuation value. But then if you take like a spline ramp and control it, you can get, contrast that way as well. Or you can plug a fit range in the middle, that's fine too. Okay, so starting from top, like you have like value noise fast. Again, you can set it to 3D input 1D noise, or you can set it to, again, 3D input 3D noise, which gives you like colored data. But yeah, for now, we'll just keep it to this. Now, default, it doesn't have fractal on. Okay, so you need to turn it on from here. Okay, so this will give you the fractal information. So you can do like standard, which is your fractal Brownian motion. This is standard. Okay, you'll get like noise. You can have terrain fractal type, and you can have hybrid terrain. Okay, so hybrid terrain is like, it gives noise in certain sections. Okay, like both terrain and hybrid terrain do that. Okay, so like standard FBM puts noise everywhere, or like puts additional roughness everywhere. And then terrain does it in like lesser areas, and hybrid terrain does it in even lesser areas. Anyway, let's keep it to standard FBM for now. Again, you have like lacunarity, which is like turbulence. Like the more you increase it, the more detail you get. Okay, like if I go all the way high, see, there you go. Okay. And then this is octaves, which is actually octaves is turbulence, right? Like if I get this down to 0, you'll get nothing. Okay, so this is 0 and this is 1. And this is 3. So the more you increase it, the more detail you get. Okay, so let's, default is 8, it's kept to 8, but you can go pretty high if you want to. Like after a while you won't see the detail until it's at shading level, or you increase the geometry enough. And then of course you have roughness, which is the amplitude. Okay, so you have sparse convolutions, which is the same as before. You can adjust frequency. For some reason, the frequency, like this is of vector 4 instead of a vector 3. Again, you can see, like if I zoom out, you can see like now you can see the star pattern, like this cross over here very clearly. So let's just make it like, we'll move the offset to 10, so we don't have to deal with it. You can also make the noise periodic, but periodic noise is a little weird to control. Okay, I'll do another lesson on periodic noise, but it's not been easy to, periodic noise, to explain it, is repeating noise. Okay, which is very useful if you want to do like tileable textures, right? Like if you want to bake this out to a tileable texture, you need it to be periodic, which is what Substance Designer does. Like in Substance Designer, all the noise maps are periodic. Like that's why you can make a texture and it's always tileable. In general 3D softwares, the noise maps are not periodic. Okay, so you have the option to make it periodic, but it's not very easy. Okay, so I got it once and now I've forgotten how I did it, but it requires a fair bit of guesswork. Okay, so I'll do another one, and then I'll do another lesson to explain how it works. Okay, so you have sparse noise, you have alligator, you have Perlin. Okay, you have Perlin flow, which is almost the same. You have like flow rotation over here. I don't know what that does. Okay, simplex. You have a bunch of stuff. Let's keep it to none. See if we can see the difference. Okay, so this is Perlin, and that's simplex. This is Perlin flow. Okay. Anyways, then this is Whirly, which is like your standard cellular noise. This is Whirly F2, F1, which is good for, So like if you're coming from a Max background, it used to be like it's circular and chips. Okay, so this is circular and then this is chips. Okay, and then you get the other fancier stuff. So you have like Manhattan, which is actually good for doing, like more circuit-like patterns. So you have Manhattan F2. So this is actually pretty good. Like if you want to do like sci-fi panels and stuff like that, you can use this. You have Chebyshev, okay, which is also good for sci-fi alien stuff. And I'll do that, like before I close this lesson, I'll just show you how to do that. Okay, then you get other things, right? So you have, of course, you have noise that you can add to these. Okay, so you have like your standard FBM and whatever. Okay, this is standard FBM, this is terrain. So you can see like with terrain, it's not adding it in the down areas, it's only adding it on top. And then this is hybrid terrain, which is even more sort of, secluded. Okay, you have warping options, so you can do like lattice warp and gradient warp. And I'm confused as to what either one of those to do, but you can just turn them on and use them. Okay, like we can increase the frequency, let's make it 10. See, there you go. Ooh, that looks fancy. Yeah, you want to do like an alien city, you could do this. Okay, but yeah, you can keep it to 2. That's not bad. Yeah, and then, so you can do lattice warp. You also have this option called accumulate lattice warp, which I don't know what that does. Okay, some things I don't understand, but you can just use them. And this is gradient warp, which is this. Okay. Oh, you can do some fancy things with this if you want to. Again, these are good for doing like, you want to do one of the, you're doing like a motion graphics thing and you want to create like random patterns and stuff like that. You can use this. Okay, then we come into other things. So you have like fold, which generally doesn't do anything. Okay, you have complement, which is reverse. Okay, like this is, or the white areas coming on top, and complement will push the white areas down. You have bias, which by default three are on, but it's a 1D noise, so you don't need to modify all 3. So you have bias, like this is like if you go to 0.9, so it's sort of like it's removing the contrast. Like if I go to 0.2, see it's, like the center area is now a lot more, smooth. And then if I come to like 0.99, so you'll notice like it does this. It's still rounded, but it's more sharper. So it's like it increases contrast. And then gain is increasing intensity. Okay, so So let's say if I take this to 0.99 and I increase the gain as well, or let's reduce it. Yeah, there you go. So you can do, like, as I said, like you can do like nice panel work with this. Okay, and then you also have like an amplitude option. So if I increase this, you'll get more amplitude. And then you have like this thing called filter scale, which again, I have no idea what that does. So let's keep it to 0. Let's keep it, default is 1. Let's keep it to 1. You can also clamp the output range if you want. So let's say maximum is 0.4. See, there you go. So you can like clamp it. So it's got like a ton of options in here, like, which is nice. Okay, let's remove the noise, or let's remove the fractal. And then let's say if I come in here and I again put in like a shape in there, like I can right click here, I can put in a ramp parameter. And let's say I'll just call this shape and spline ramp. And then I can just take this and bring it up. And we'll keep it to linear. So I can just see. So you can like, do things like that. You can just take this. See, there you go. So you want to do like remove, like lower the displacement height. So you can do things like these. Okay, now before I close this, there's like a few things you can do with this. Okay, like let's say if I change this to Manhattan. Okay, so this is Manhattan, and we might have to adjust this. So Manhattan generally gives you diamonds, but let's say if you want these to be squares. Okay, like let's just give them enough, and let's also give it like standard FBN, but I'll bring this down to 3. And I'll lower the roughness, I'll lower the, or let's just keep it to 2. Okay. So let's say if you want to rotate these, right? Like let's say you want these to be square. So what you can do is between the position and here, I can put in like a transform matrix. So if you put in a transform matrix, that will give you like, some basic controls. So I can do a rotation now. So let's say if I rotate it in X by 45 degrees, see, this gives you different patterns. Okay. Like if I take this and I kind of like, compress it down, see. So by rotating the noise maps, you can get, some nice additional patterns. Like if I come to Manhattan F1, F2, okay, or like, see, so this is what, like if I bring this in, see, so this is completely different from what I was getting before, right? Like, so if I get the X form down to 0, see, this is what I was getting before. And then if I rotate it to 90, you get like, different results. Or let's say if it's 30 degrees, see. Okay, so if I go back to Manhattan, okay, let's do like Manhattan cellular, and then I can take, let's take the y-axis and make it 90. Sorry, no, let's do 45. See, there you go. So now you can get squares. So depending on what axis you are in, you rotate it in that particular axis, and then I can just, adjust this. So if you want to do like, rectangles and stuff, you can do this. Okay. So you can do, like stuff like this. I can probably like flip it. So you get this. Okay. And then if I come into like Chebyshev, it might be, see, so this goes in the other way. Because if I make this 0, you can get squares. Okay. Let's try to increase this. Yeah, that kind of distorts it, so it's not really very useful. Okay, and as a final thing, let's say if you want to animate this, okay, so like you have a bunch of ways to do it, but you can actually animate it, right here in the X form, right? Like if I take this translate and I move it in the Y-axis, you'll notice this changing. So let's say if I come back to the grid, I'll make it 512 because that will sort of, make it go faster. And what I can do is if I come in here and let's say for fun, I'll just go back to cellular. So you get like dots. Okay, but smaller dots. Okay. Now this is where it becomes nice, because what I can do is if I change these to, let's say, B-spline for all of these. So if you want to do like, smoother this thing. So what I can do is let me just try, if I want this to be, like rounded. Okay, let me just do one thing. Let's try to make this linear. Yeah, there you go. See, so now you can have, like they'll be like dome, like, okay, or I can take this, or, like you want to do ripples, so you can do that. Okay, but let's keep it to this. And if I come back into my displays and I increase this, see. Yeah, and then what I can do is if I want to animate this, so you can take, you have a bunch of options, right? So one is you can animate the offset, but if you don't want to animate the offset, we can animate the transform matrix. So what I can do is I can take a float to vector and I can take the time. Okay, so I can take the time and let's say, so X and Z will make it move sideways. So what we want to do is we want to move it in the Y axis. Okay, and then I can take this and also just for control, I'll add like a multiply constant in the middle. So I can control the speed and then just plug this into the translate. And what this should do is if we press play, yeah, so if I press play, you'll get this. So yeah, so now we can like switch it over to anything we want. Okay, it should look interesting. Like let's say even if we do like Berlin flow, no, this is like, I think we might need to increase this a bit. Yeah, there we go. Oh, that looks nice. Or whatever, like we can try to do, I don't know what Chebyshev will look like, but this should be interesting. Oh, that does look fancy. Yeah. So you can do some nice fancy patterns with this if you want to, you know. Like this is, see, this is where the shape node or where our spline ramp comes into play. Like this is like a dome right now, right? Like if I change this to, you know, like linear or see, so there you go. So now it's flat or whatever. Like let's try to do Hermite. Oh, that isn't bad. Okay, the Hermite gives you like an absolute flat node over there like that. So you can do things like these. And let's try to make it periodic. I don't know what periodic does, but okay, let's not do periodic. As I said, I'll figure it out and I'll, you know, make another video on periodic. Yeah, so animating these is pretty simple as well. Okay, like if you can promote the parameters and then animate it at, you know, at SOP level, but if you just want to animate them inside, you can just take a time node and plug it in, you know, like that works perfectly fine as well. Okay, so this is as far as, you know, your major two noise maps are concerned in Houdini. Okay, so the next lesson, we'll take a look at how to modify noise maps. Okay, so if you want to distort noise maps or you want to mirror noise maps and, you know, stuff like that, we'll take a look at those things.